Welcome back, guys, to the channel, and welcome back to the part 2 of the Part.3 2.2 meter matrix build. So far the build has been pretty straightforward. We got the turbine installed, the fuel tank cleaned up, and the fuel plumbing all set up and ready to go. So all that's left is just the electronics, and then just putting on a few more items left in the jet. But before we get started with that build process, something came in the mail today, so let's take a look at what this package is that came in from Banana Hobby. Just going to tear this bag open and take a look at what we got in here. Alright, looks like more swag from Banana Hobby. So Carrie from Banana Hobby sent me a hoodie. Pretty cool, and it's perfect timing to get one of these from Banana Hobbies, because it's winter, it's starting to get cold out. Granted, it doesn't snow here in Florida, but it does get pretty chilly in the morning. So before we get started on the build, let's put on a more appropriate attire and get started with part 2 of the Part.3 matrix build. Alright guys, so here is what's left that needs to get installed into the jet, and basically it's just the battery and the 2 receivers that's going into the matrix. Now I wanted to take the moment to kind of share with you guys a product that I've been using for the past 3 years now. When it comes to receiver batteries, I use AR Power's lithium ion receiver packs. So this compact 2-cell 7.4 volts is packing 3200 milliamps for its compact size. As far as weight, this receiver pack comes in at 4.4 ounces. Now I use this lithium ion receiver packs on all my jet builds, from the 2 meter Predator, 1.8 meter BA Hawk, the Part.3 1.8 meter F-16, and then now it's going into this matrix. And it's kind of one of those things where you find a product that works for you, you tend to stick with it. Well, this is one of those products that has really stuck with me for the past 3 years now, and I continue to purchase them and put them on my future builds. So both of these receiver packs should come in at roughly, I don't know, 9 pounds, give or take, or 9 ounces, not pounds. So yeah, about 8.9 ounces. Not too bad for 2 receiver packs, and especially they're 3200 milliamps. And then for the ECU, we're going to be using the Live 3800 milliamp by Pulse. Now I already kind of got started with installing some of the electrical components on this jet, so I'm just going to give you guys a quick look at what the component tray layout looks like, and then move on to the final wiring of this jet. So I may actually have to make my own servo leads again, make some extensions for a couple of the leads that is not going to reach the Power Box Pioneer, but I'll show you guys how I do all that process. Alright guys, so now it is time to unveil the component tray on the new Part.3 matrix. Now I am a little OCD when it comes to building turbine jets, and it has to look clean and presentable. So I hope you guys like what I did with it, and I'll also include on the description below the list of parts that I used to put this component tray together. So without further ado, here is my component tray on the Part.3 matrix. Now, starting from the top left, we got our KingTech ECU. To the right is the Asan AG68 retract controller with brake assist and no steering gyro, the Power Box iSat gyro, and then Power Box Pioneer, and then we got our on and off switch right down here. So I decided to put the layout this way, so that way, one, for the Power Box Pioneer, when I'm done flying and need to recharge the battery, I just simply disconnect the power battery plugs on both sides, and then plug my charger or my charging cable there to charge the ECU or the receiver packs. As far as the Asan AG68 brake assist and retract controller all in one, I decided to just keep the AG68 installed and not use the Pilot RC retract controller. And I just kind of weighed in, what are my benefits here? With the Pilot RC retract controller, I have the option of being able to service the retracts without having to power on the jet and my transmitter. You can basically just push the little button on the side. Let me see if I can show you guys. So I can push and hold this button right here, and it'll drop the retracts or retract it if I ever need to service this jet without having to completely power everything on. And then the benefits of the Asan AG68 all-in-one with retract controller, brake assist, and nose steering. Now, there's a little bit more benefits to using this instead of having the retract controller by Pilot, and it's because the nose steering gyro keeps the nose of the aircraft perfectly straight down the runway during takeoff and landing. The brake assist, if the gyro detects that the jet is starting to drift one side, left or right, it'll automatically apply more power or braking force to the opposite tire to prevent the jet from doing the Tokyo drift, is what I call it. Basically fishtailing when you're coming into a stop. I've used the AG63 in the past and the AG68 on all of my jets from EDF to turbine jet, and it just makes it so effortless during takeoff and landing. Once that jet nose is pointed straight down the runway, it is going to stay straight down the runway, and pretty much every landing, I don't even touch the rudder. As long as the jet is straight down the runway, I just hit the brakes and I don't even touch the rudder to keep the jet straight. So it's just one less thing for you to worry about when you're taking off and landing, and it just makes it that much more enjoyable to fly when you have less things to worry about when you're flying this model. So that's why I decided to just stay with the Asan AG68, and I'll show you guys how to program one of these things. They are definitely one of those products that have also stuck with me for a long time because they just work every time and they work really, really well. So I hope you guys like how the layout of the component tray turned out. Now let's go ahead and get started with the setup of the battery tray to the nose for the ECU and the receiver packs, and then create all the extensions that is necessary to make the connections to the component tray. So let's go ahead and get started with that part of the build. Alright, so this is going to be just a build tip, something that I've learned over the past few years of building turbine jets, and I think it's something that a lot of us don't really spend a whole lot of time or even think of doing when we get our brand new jet. I know we all get excited and we want to put the jet together so that we can go out there and fly it, and then we have instances where a servo would burn out on us on maiden flight or even a couple of flights in. And I think that if we kind of narrow down or eliminate some of the possibilities of what caused that servo to amp out or overheat and fail during flight, I think we'd be better off and have a much better success with our maiden flights and prolonging or extending the life of our models. So this is more of a build tip that I learned over the past few years again, and which is anytime that I get a brand new jet, I typically would disconnect the control rods and inspect the live hinges. Checking for any tears on the live hinges on this model. I don't see any. Now the next thing that I would do is break in the live hinges. So if you guys can see, the live hinges are still fairly, they're kind of broken in, but they're not freely moving as they should. So what I like to do is just basically, move the control surface about 20 degrees initially and just kind of work that live hinges both direction. And the reason why I do this is that the live hinges are still brand new, they still haven't been broken in, and if you went out to go and fly this model, you're basically putting the servos in an added stress and load to that servo, because now it's having to push harder because the live hinges aren't completely broken in. So I typically would just start at 40 degrees and just work it, and then increase it to about 30 degrees, and then all the way up to 45 degrees, or whatever the maximum throw on that control surface is per the manual. Now here's an example why I inspected, and I will show you guys. This is the left side of the horizontal stab, and I notice how on the down elevator position I'm getting quite a bit of deflection, but when I move it to the up elevator position, it starts to have resistance right around that spot. And on the manual, it talks about the up elevator being at 26 millimeters, and when I measured it, I'm barely getting that 26 millimeters right now. Now granted, the servo will push it, but you're adding a lot of extra strain and load to that servo, and potentially causing that servo to overheat, amp out, or fail on you over time, or maybe even doing maiden. But if I would just work this elevator very slowly and just breaking that live hinges in, I'll eliminate some of that stress that the servo is going to be put under, and basically increasing my chance of success during maiden and future flights that I'm going to have with this matrix. So it's just one of those things that if you just take your time and actually do the extra step the first time, you'll have a much better success with your jet. Alright guys, so here we got the one of the wing harnesses for the Matrix. This is the 4-to-1 connector that was installed on the jet from the factory. One thing I wanted to point out to you guys that I noticed pilots started doing is that in the past they would have the MPX connector and just basically solder the wires into the pins. What I would do, and I've done in the past, is ordering some of these PCB boards where I would solder the pins to that PCB board and then the wires. And what that does for me is basically I have something to hold on to, so I'm not putting any strain on the wires when I'm connecting it into the wing, and then when I'm done I'm not tugging on that wire. So having the PCB board really helps out to have just something more surface to hold on to when you're installing and removing the wing. Now Pilot started doing that, so I was actually kind of glad that they did that, because I didn't have to redo the wirings on the pins, and that just kind of helps eliminate some of the issues that you'll have later on, possibly tugging on the wires too hard and then you accidentally pull the aileron leads off of the pins, and that would be a terrible day. And then another thing I'm going to do to this wiring harness is I'm going to put this wire loom just to kind of clean it up, and then also remove some of this, or actually remove all of these labels, and I'm going to swap them out with one of these heat shrink tube labels. Now I got this from Amazon, which is pretty cool, and it just kind of works with any sticker label that you have at home. So all I'm going to do is just cut these labels, slide it into the wire leads, and then just use my heat gun and just kind of shrink it up so that way it looks a little cleaner. So I'm going to go ahead and get started with that, and I'll see you guys in the next step of this build. Alright, so here's the finished product. So pretty much cleaned up a little bit, wire loom, basically replaced those tabs, labels that came with the factory, and used the heat shrink tube label maker. Ready to put this back in the jet. Alright, so we pretty much just need to install the ECU battery on the Matrix. So the battery tray on this jet pretty much just looks like this, and it slides forward on the nose. So where this battery tray slides into, if you guys can see, there's a little latch right there that you can lock into place by lifting the latch up and then sliding it left or right, and then that'll lock the pin in the up position so that you can slide the battery tray forward. And then there's a little hole right here that is pre-drilled into the former where that latch is going to basically lock itself in. So basically we're just going to slide this forward, and once you got it in position, go ahead and release the lock. There we go. Latch it down, and now that battery tray doesn't go anywhere. So I'm just going to go ahead and tidy this up and make the wires kind of tucked in back here so that it's not flapping around, and then I'll show you guys the rest of the jet. Alright guys, we are officially build complete on the new Pilot RC 2.2 meter Matrix. So now let's go over some of the control throws and the CG on this jet to get it that much, one step closer from taking it out to the field to do our maiden flight. So as far as the aileron throws, you're setting up with 18 millimeters of deflection. And then for the elevators, it's 26 millimeters up and down. Alright. And then for the rudder, it's 50 millimeters deflection for both sides. And then for our flaps, it's 25 millimeters for the takeoff, and then 95 millimeters for landing. Now, as far as CG of this plane is from the leading edge back 253 millimeters. Part.3 does include one of these CG jigs with every kit, and it just basically these wood formers sandwiches in between the wing and the fuselage, and you just take a tube or maybe a spar, wing spar that you guys have, and just basically suspend the jet in the air to get it to CG. Now, I do want to point out that with using the CG jig, it did show that the jet is very nose heavy because the main wheels wouldn't even come off the ground. So what I ended up doing was doing my measurements and used my Sequoia digital CG scale, and I'm going to share you guys the measurements that I use on mine. So from the mains to the nose gear, it's 966 millimeters distance. From the mains to the CG is at 32 millimeters, and then from mains to the counterweight balance was 988 millimeters. Now, as far as weight, so this jet complete dry with just UAT full came out at 23.91 pounds. At half a tank, it came out at 25.96 pounds. 3/4 full is 27.72, and fully fueled is at 29.39 pounds. Not too shabby for a 2-meter jet, honestly. It's actually still relatively light. So I'm pretty much ready to go and take this jet to the field and do our maiden flight. So I will see you guys on the runway for the maiden on the 2.2 meter Part.3 Matrix.